And the reason I had started off the lesson talking about exponential and I'm ending the lesson talking about logs is because they are directly related. So we know if I have something like 2 to the 4th power, we would know that just means we are going to multiply 2 times itself 4 times, and we would end up with 16. So now that's exponential, right? I have some base, I raise it to a numerical exponent, and I just solve for it. What logs does is it almost works the other way around. They say, okay, well, I know I have some base of 2. I'm sorry, I have a base of 2 raised to some unknown exponent, and that's going to give me 16. So essentially, what logs does, it's asking you, what power do I need to raise this 2 to get 16? And we can all solve this pretty easily, right? What power do I need to raise 2 to get 16? The 4th, right? We know this. We can solve this easily. They're not always going to be so easy to solve for. And so the way this is still written as exponential. So the way this is written is still considered an exponential form. But we can write this exponential form as a log. How would I write this as a log? So if I have 2 to some power equals 16 and I wanted to write this as a log, it would look like this. So you're going to write the word log, and whatever the base in the exponential is, that's going to be the base of the log. So what's the base in this exponential? 2. So it's going to be log base of 2. So you write it almost like a subscript to the log. And then I'm going to open a set of parentheses. What comes next after the base of 2, this is called the argument. And what you write in the argument is what it equals. So here it's 16 equals what we're solving for, which is the exponent x. All right, so this is our base. This 16 is called the argument. And we can go both ways. What do I mean when I say we can go both ways? I mean, if I have an exponential equation like this, I could write it as a log, but also if I have a log equation like this, I could go back and write it as an exponential. So it goes both ways. So the general form of a log will be log. Our subscript here is our base, whatever the base is. The argument is actually the answer. Equals the exponent. And this is basically how we set up a log equation. Okay, let's do some sample problems. So let's say I have log base 3 of 81. And that's how you would read that, log base 3 of 81. Notice I don't have an equation. Do we all agree? This is not an equation. It doesn't need to be. When we have a log, it doesn't need to be an equation. If there is no equation, you can always, if it makes you feel better, write equals x. Actually, write it underneath. If it makes you feel better, you can always then write equals x. And now in order to solve or simplify, I would generally say simplify this log. If I were to simplify this log, what I would do is I would put it back into exponential. So I need to remember, if I'm putting this back into exponential, it's the log base answer equals exponent. So what does this look like? Log base answer equals exponent. It looks like my base is 3. What's my exponent? What's my exponent here? X equals what? 81. And ultimately, what am I solving for? We're solving for x. So they're saying 3 to what power gives us 81? 4. We can figure this out in our head, right? Let's say it wasn't that easy to figure out in your head. What you would do is we would try to make them into the same base, and you always go smaller. You're always trying to go to the smaller base. So I would leave 3 to the x power, and then I'd say, okay, is there a way to make 81 have a base of 3? Yeah, absolutely. I could make 81 have a base of 3 if I do 3 raised to the 4th power. Do we agree? So now since they have the same base and they're equal to each other, then we can say x is equal to 4. So when I say simplify log base 3 of 81, we're going to say, okay, well, that simplifies down to 4. Okay, you guys try this one. Log base 2 of 64. So some of these logs we can do in our head. So can somebody tell me log base 2 of 64, what is this asking? When I say log base 2 of 64. Ariana? Excellent. 2 to what power gives us 64? So 2 to what power gives us 64? 2 to the 6 power? No. Yeah. 6? Oh, yes, you're right. 6. No, I wrote 5. 6. Perfect. Okay, let's say I ask log base 100 of 1. Do we all agree this is saying 100 to what power gives us 1? That's what this is saying. What power always gives us 1? 0. So this is 0. Log base 100 of 1 is 0. Okay, remember I had introduced E when we were graphing exponentials, and I had said for the purpose of graphing, we just needed to know that E was greater than 1, so it was increasing, right? Do we remember that? Okay, well, E shows up in logs also. And sometimes, well, not really sometimes, but if I have log with a base of E, it is never written as log base E. Whenever we have a log base E, it is never written as log base E. It is always written as ln. And so whenever you see ln, what do we need to know? We need to know that this is log base E. And when you say ln, it's called the natural log. Another thing to know, if I don't have a base written down, let's just say I have log of 100. Do you guys see that? No base written down. So whenever we have a log without a base, that's not ln, right? ln is log base e. But if I just have a normal log written down without a base, it is always a base of 10. So if there's no base written, it will be a base of 10. No base written will be a base of 10. So what is log of 100? 2. Yeah, very good. Okay, so we now know how logs and exponential are related. Now let's talk about graphing logs. Okay, so we know an exponential function looks something like y equals b to the x power, right? Some base raised to the x power. Before shifting, this would be like a paragraph. If I wanted to find the inverse of an exponential, what would I have to do? If I give you an equation and I ask you to find the inverse, how do we find an inverse if I give you an equation? Anybody remember algebraically what we do? Well, you swap. Good. The first step is to swap x and y. And then do what? Solve for y. So whenever we find an inverse, we switch x and y, then solve for y. But can I solve for y as an exponent? I cannot solve for y. So if I have an exponential function and I want to find the inverse equation of that exponential function, our normal algebraic method says switch x and y, then solve for y. But when we do that for an exponential, we get to sort of a standstill. We have a block in the road. We cannot solve for y because it's in an exponent. So that's where logs come into play. So let's put a star here. And we're going to say the inverse of an exponential function is a logarithmic function. Okay, so what do we do for this? So let's go back. y equals b to the x power. Can I write this exponential as a log? Absolutely. Can I write any exponential as a log? So remember, the rule is log base, our argument is our answer, equals exponent. So if I want to write y equals b raised to the x power as a log, do we all agree it's going to be log base b of y equals x? Yes, we good? Okay, so now let's talk about the inverse. So I'm going to go to my log equation now, because we know this exponential and the log, they're the same. So now I'm going to go to my log equation and I'm going to find the inverse using the log. Well, the inverse, to solve algebraically for an inverse, doesn't it say switch x and y? And then solve for what? Y. So let's do that. Let's switch x and y. So I'm going to have log base b of x equals y. Well, is y already solved for? Yeah, so we're good. So this is our inverse equation. So now what would this look like? Let's think about this. So I want us to graph y equals 2 to the x power and its inverse. Well, isn't y equals 2 to the x power just a parent graph? So what's my key point for y equals 2 to the x? Ariana? 0, 1. And don't we have a horizontal asymptote 1 unit below the key point? So it looks something like this. Do we agree? Okay, so this is y equals 2 to the x power. Now what I want to do is I want to graph its inverse. Now the inverse is going to be x equals 2 to the y power. I'm going to make a chart. And normally, when we have a chart, don't we plug in for x and find y? But since this is an inverse and I'm actually solving for x, would it make more sense to plug in for y and then find x? So I'm going to plug in for y. So let's plug in for y. I'm going to say -1 for y. If y is -1, x is going to be equal to 2 to the negative first power. So do we agree that's going to be a half? Okay, so that's when y is -1. Let's do 0. When y is 0, x is what? All right, let's do +1. When y is +1, x is 2. So let's plot those points. We have the point -1, a half. Sorry, a half -1. I read that long. A half -1, about right here. We have the point 2, 0. We have the point, oh, sorry, 1, 0, not 2, 0, 1, 0. And we have the point 2, 1. Does anybody remember way back when we first talked about inverses, I had said the inverse of a function is like reflecting it over some line. Does anybody remember what that line was that I said we were reflecting it over? Johan? Y equals X, perfect. So look here. If I were to reflect this over the line Y equals X, it's going to look something like that. Do we agree? Now, also, when you have a set of points and you go to find the inverse of the set of points, what are you switching? So when you have a set of points and you go to find the inverse of the set of points, what are you switching? You're switching X and Y. We only had one main point in our exponential. And wasn't that the point, the key point 0, 1? So now that key point 0, 1 should become the point 1, 0. Did we have that? Yeah. So let's summarize the inverse. So put a star here. We're going to say reflection over line Y equals X. All right. So now let's talk about everything we need to know about the inverse. Y equals log B of X, log base B of X. So the inverse is always written as a log. But for the purposes of graphing, we always change it back into exponential. So it would be B to the Y equals X. Our key point is no longer the point 0, 1, right? Because now it's the inverse. So what's our key point? Not 0, 1, but 1, 0. We have an asymptote, but it's no longer a horizontal asymptote. It's going to be a vertical asymptote. One unit to the left of the key point. And for the shifting, it's going to look like B raised to the Y minus K plus H equals X. And I think we all know H represents what? Horizontal shift of key point. And K represents the vertical shift of key point. Okay, let's do a couple sample problems. Oh, sorry, guys. Do okay. So for this, as a log, it doesn't really mean much to me. So what I'm going to do is I'm going to put it back into exponential to get a better idea of what this looks like. Can somebody tell me how would I put this log equation back into exponential? Ariana? You got it. Half to the y power equals x. So you tell me, is this a normal exponential or is it the inverse of an exponential? And how do you know? This is an inverse. How do we know? Because x and y have been switched, right? So because this is an inverse, has it shifted at all? Nope, it has not shifted at all. So we're gonna go here. We're going to say my key point is the point 1, 0. Do we have a horizontal asymptote here? Horizontal asymptote? Nope, we're gonna have a vertical asymptote where? 1 unit to the left of the key point. And now remember our rules for exponential, it's still going to be the same. Because my base is greater than 0 but less than 1, am I increasing or am I decreasing? Decreasing, right? So because my base is greater than 0 but less than 1, my graph is decreasing. So what does that look like? I'm going to hug from the top here, but then go down. So let's answer some questions here. What is the key point? 1, 0. What is the equation of the asymptote here? Perfect. What is my domain? Domain. Guys, more than Ariana should know this. Ira? You got it. X such that x is greater than 0. It's not equal to 0 because the asymptote is there, right? What is my range? Charlie? All real numbers. Perfect. All right, let's step up a little bit. let's say I have y is equal to log base 2. And in my argument, it's going to be x plus 1. Close your parentheses, and then I'm going to have minus 3. I want to change this back to exponential. But in order for me to change it back to exponential, I need the log, the base, and the argument on one side. Okay, I cannot subtract that -3 and the 1 because the 1 is part of the argument. That -3 is not part of the argument. Does anybody need me to say that again? So right now, I cannot combine the 1 and the -3 because the 1 is part of the argument, the 3 is not. So in order for me to change this back to exponential, I need to just have the log, the base, and the argument on one side, which means I have to move that -3 to the other side. How do I move that -3 to the other side? We're going to add it, exactly. So we're going to now have y plus 3 is equal to log base 2 of x plus 1. And now I change this into exponential. So it's going to be 2 raised to the y plus 3 power equals x plus 1. Right? Log, base, answer equals exponent. Do we recognize this as an inverse because x and y have been switched? All right, before I graph this, do we agree the x has to be by itself? So what should I do? Subtract that 1, exactly. So we're going to have x is equal to 2 raised to the y plus 3 power minus 1. So now this is an inverse that has been shifted. Do we agree? This is an inverse that has been shifted. So let's do our sketch. The key point for my parent graph for the inverse is the point 1, 0. But now I'm shifting this. I'm shifting this 1 unit where? Shifting the key point 1 unit where? Because it's usually 2 raised to the y minus k plus h, right? So do we agree we're shifting 1 unit to the left? And then 3 units where? Not up, down. So this is my new key point. And then I'm going to have a vertical asymptote, 1 unit to the left of that. Now, should my line be increasing or decreasing? Or my graph, I should say, not my line. Should my graph be increasing or decreasing, and how do we know? You got it. Increasing because the base is greater than 1. So let me actually extend this a little bit more. So it looks like it's going to be something like that. I could potentially find my x-intercept in this one because it would be x is equal to the 0 plus 3 minus 1. So x is equal to 2 to the 3rd minus 1. So we're going to have x is equal to 7. So we could have an x-intercept of 7, 1, 2, 3, 4, 5, 6, 7. So it'd really be exaggerated there, but that's not really the point of this. It's just a general idea of where it's going. All right, last problem for today. Okay. This plus 1 is not with the this plus 1 is not with the argument. So how this looks is ln of x, maybe I should have put the parentheses there on the test. I'll make sure I put the parentheses to make it very clear, plus 1. So before I change this back into exponential, do we all agree I need to get rid of that 1? So this is going to be y minus 1 equals the ln of x. And do we all agree the ln is log base e of x? So we're going to have e to the y minus 1 equals x. Are we in a good format right now? Yeah, we're in a great format. X is by itself. We know it's an inverse because x and y have been switched. And do we agree this is just an increasing inverse? So my key point for my parent graph would have been the point 1, 0. But now I have shifted this 1 unit where? Up. We're going to have that vertical asymptote 1 unit to the left. And we are increasing, so it looks something like that. Like I said, it's just very generalized sketches. All right, this is where we stop.